Jai Hind everyone. Myself Puneet Saini, Assistant Professor Mechanical Engineering Department, Ajay Kumar Garg Engineering College. So today is the second lecture of our subject Mechatronics, which code is KME052. In our first lecture, we discussed about Unit 1, which was Mechatronics and its scope, in which we discussed about the introduction to mechatronics, what was the definition of mechatronics, what was the evolution, and how in recent years it is integrated with Industrial Revolution 4.0. So today we will be discussing about second unit, and in this second unit we will be discussing about the definition of sensors and transducers, and about the performance terminologies, and two type of displacement sensor, which is ultrasonic sensor and another one is Hall effect sensors. So this whole subject is divided into 5 units, and unit 1, as I have told earlier, deals about the introduction of mechatronics. Unit 2 deals about the sensors and transducers, which is the input devices to any mechatronic system. Input devices meaning we gather information from these devices, which are sensors. And unit 3 deals about the output devices. Output devices mean after gathering information from the sensors, a controller takes a decision whether the certain specific task has to be completed or not. After taking this decision, it has been passed on to the output devices. And some example of output devices are electrical actuators, motors, mechanical actuators like cam, gears, etc. So these are some of the example of output devices. So unit 3 deals with the output devices, and unit 4 deals with the controller, which is essentially acts as the bridge between the input and output devices. It helps to take the decision whether certain task is to be completed or not. And in controllers, we will be discussing about the PLCs, which is known as programmable logic controller, which are used in industries. And unit 5 deals with the applications of mechatronic system. So these are total 5 units, and today we will be dealing about the input devices, which are sensors and transducers. So let us start our unit 2, sensors and transducers. So if I talk about this term sensors, we all know that human beings also have sensory organs. Like for example, if I take my nose help me to smell things, so it's a sensory organ. My ear helps me to listen things, and my tongue helps me to taste different delicious foods. So all these things are known as sensory organs, which helps me to sense the changes in the environment and let me take the decision whether that for example, if I am having a delicious food, whether that food was tasty or it was not. So it helps me, these sensory organs helps me to take the decision. And the brain, which is also known as the controller, helps me to decide whether that decision was right or not. So let us start this unit. So as this is an engineering based project, industry based subject, so we will be dealing about the sensors in terms of manufacturing and what types of sensors are used in industries. So if I talk about sensors in industries or in manufacturing sector, they are basically employed to automatically carry out production operations as well as process monitoring activities. For example, in automobile industries, many of the industries are now switching to robotics, and in many industries, robots are used for different applications, like for welding purposes, for pick and place operation, for spray painting, deburring. So on these different types of robots, sensors are being mounted. For example, if I talk about pick and place robot, sensors are being mounted whether to see the object has been grappled in the right position or not, or whether the object is in the close vicinity or not. So these sensors are used in industries for various applications, like for process monitoring applications. And has the following important advantages to transform conventional machining into a modern one. So this is what mechatronics is all about. We are integrating different mechanical equipments with the electronics equipment to enhance our production and enhance our production line. So sensors, now these 3 points are some of the examples of sensors, how they are improving our conventional practices with mechatronics one. Now sensors alarm the system operators about the failure of any subunit of manufacturing system. So if there is any failure in the manufacturing system, for example, some assembly line is not working properly, the sensor will automatically sense that and will send the message to the operator that there is a specific amount of fault in that area of the machine. So the worker or the person who is dealing or the operator who is dealing with the machine will only have to go to that space and complete the fault by carrying the preventive measures. So what another example of sensor is it reduces the requirement of skilled and experienced laborers, and ultra precision in product quality can be achieved. So these are some of the broad examples of sensors and how they are helpful in industry. So now you from all this studying this paragraph, you may have developed an understanding like the sensors in industries are used to help the workers who are working in the assembly line or in the manufacturing unit to see whether the production line is performing well or not. So these are the application of sensors in industry. Now what is a sensor? If I talk about the definition of the sensor, a sensor is a device which detects or measures a physical property and records, indicates or otherwise responds to it. A physical property can be anything. Suppose we have a temperature based sensor which senses the temperature. If the temperature exceeds a certain limit which was set to it, it will send the message to the operator, yes, the device is getting heated, you need to turn off the device, or you need to turn on the service of the coolant, that the device is exceeding a certain temperature limit. So it, in our case, like I gave the example of temperature, it's a device which detects or measures a physical property which can be temperature and records, maintains the data, indicates or otherwise responds to it. Responds to it means it will send the message to the controller like the temperature has exceeded a certain limit and you need to do something about it. So this is the definition of the sensor. Now let us come another definition which is part of this unit, which is transducer. Now it is defined as an element when subjected to some physical change, experience a related change, or an element which converts a specified measurand means a quantity which you are measuring, into a usable output by using transduction principle. It measures a physical change and responds to it. So let us understand the definition of transducer with the help of an example. So a wire of constant 10 alloy, which is a mixture of copper and nickel, which is for 55% copper and 45% nickel, it's an alloy and can be called as a sensor because variation in mechanical displacement like tension or compression sensor, it senses and it sends the signal with the wire, it becomes compressed or become tensed, can be sensed as change in electrical resistance. So if there is a change in electrical resistance, then the wire may compressed or it become tensed, right? So if it responds, wire responds in that way, it compresses or it comes in tension, then we say that this constant and alloy is a sensor because it is responding to the change of resistance in the displacement of the wire, right? Now if what else I can do is, if this wire becomes a transducer with appropriate electrodes. Now if I apply appropriate electrodes to the wire and input output mechanism attached to it, and with the help of this wire I attach an input output mechanism, for example, to control the flow of the fluid or liquid, then thus we can say that the sensors are transducer, meaning if a sensor can be called as a transducer, then we can say or sensors are transducers. The sensor can be said a transducer if with the help of that change we can get some appropriate output, then we can say that that sensor is a transducer. So this is a definition of the transducer. Now let us proceed. After studying the definition of sensors and transducers, we discuss about its various specifications. Now transducers or measurement systems are not perfect system, as we know that no machine is perfect. So mechatronics design engineer must know the capability and shortcoming of a transducer or measurement system to properly assess its performance. For example, a temperature sensor, if I may take the example of a temperature sensor, it may sense temperature between the ranges of suppose 45 to 110 degree. So that is a range of the sensor of temperature sensor, and beyond that or below that it will not be able to measure it. So an engineer must know which type of sensor do they use, what is the range of it, what kind of error it will give. So they have to be very careful about selecting the sensor. So it comes under the category of specification. So a engineer, mechatronics engineer, must know about all these specifications. Sensor specifications inform the user about deviation from the ideal behavior of the sensor. Following are the various specifications of sensor transfer system. So first will be is range. So a range of a sensor indicates, now this is the terminology which you all need to remember, and in an exam it can also be asked. ये exam में पूछी जा सकती है कि range क्या होता है and span क्या होता है in 2 marks question in AKTU examination. All right. So the range of sensor indicates the limit which with the input can vary. And for example, a thermocouple for the measurement of the temperature might have a range of 25 to 25 degree. So thermocouple is a sensor which measures the temperature, and it might have a range of this, right? So this is known as range. Now second is span. The span is the difference between maximum and minimum values of the input. For example, this is the minimum value which this temperature sensor can measure, and this is the maximum value which a temperature sensor can measure. So if we divide these two, then we will get the span, the maximum, the minimum values of the input. Thus the above mentioned thermocouple will have a span of 200 degrees. So this is the range through which our temperature sensor, which is a thermocouple in our scenario, will measure. Now third type of specification is the error. How would you define an error? An error is the difference between the result of the measurement and the true value of the quantity being measured. Suppose the difference came out to be, if the displacement sensor gives the displacement come out to be 20 mm and actually come out to be 19.8 mm, and actually it was 20 mm. So there is an error of 0.2. So this is known as error. A sensor might give a displacement reading of 29.8 mm and actual displacement was 30 mm. So the error is minus 0.2. So this is known as error. So you have to be very careful also by seeing which type of sensor gives the minimum amount of error, right? So this is what you need to understand. Now next come non-linearity, number 4. Now the non-linearity indicates the maximum deviation of the actual measurement curve. Maximum deviation of the actual measurement curve. So suppose this is the input and output relation. If I want to show the non-linearity with the help of this graph, now this is the measurement curve, this, and this is the ideal curve. Now the maximum deviation from the ideal curve and measurement curve can give. So this is the maximum deviation, that is known as the maximum error or non-linearity of the actual measurement curve of the sensor from the ideal curve. Figure shows a somewhat exaggerated relationship. So this is not exact, like in actually this is not the case where the error is this much big, non-linearity error is this much big, or least square fit line and the actual measured calibration line. Linearity is often specified in terms of percentage, which is defined as, so we express the non-linearity error in terms of percentage like 5% or 10% or 1%, maximum deviation in input divided by maximum full scale input. So this is how we represent the non-linearity error. Next come is the hysteresis error. Now here we have measured the error as in horizontal term. Here the error is being measured as vertical term. Now here we have drawn the graph with the help of an input which is defined as the heat flux, which unit is watt per meter square, also defined by Q or small q, and here is the temperature. So as the temperature increases, and this is the error which we receive, there is a measured and the output. So it is an error of a sensor which is defined as the maximum difference in output at any measurement value. Maximum difference in output. So suppose this is the output and the maximum difference, this is the input. Within the sensor specified range, when approaching the first point with the increasing and then with the decreasing. First point increasing, suppose here it is increasing, and then the maximum point of decreasing. So eventually it will give us the vertical value. So this is known as the hysteresis error. Figure shows the hysteresis error might have been occurred during the measurement of temperature using a thermocouple. The hysteresis error value is normally specified as a positive or negative percentage of the specified input range. So it can be positive value or it can be a negative value. Now, after seeing the specification, these apart from these four types of specification that we have studied, there are many more specification of sensors which is not possible to study right now. So we will be moving on to our next topic, which is the types of sensors. So if I talk about the displacement sensors, which is in your syllabus that we have to study. So these are some of the types of displacement sensors. Which is in your syllabus. All right. So one is potentiometer, strain gauge element, capacitive element, transformers, eddy current, inductive, optical encoders, pneumatic sensor, proximity, Hall effect sensors. So you don't have to study all of them. It is not in your syllabus, but in case you have curiosity and you want to study what are the different types of displacement sensors, then you can see. So let us see the definition. What is the displacement and position sensor? As evident from the name, if you want to measure the distance from one object to another object, then we can say that we have to use a displacement sensor, right? So are basically used for the measurement of movement of an object. Position sensors are employed to determine the position of an object in relation with some reference point. Like they are pretty useful in the manufacturing industry. Like proximity sensor are the type of position sensors and are used to trace when object has moved within the particular critical distance of a transducer. Now the best example of proximity sensor that I give is this mobile phone. Like when we call someone and the screen is on, and as we put this phone near to our ear, the screen goes off. This is because of the proximity sensor present here, and there is a specified value on this proximity sensor in which as you put close to your ear, the lights goes off. The sensor sends the message to the controller that the person face, or it can be anything. If you if you keep it in your pockets also, then the lights goes off, and it tells that you need to turn off the lights, right? Otherwise somehow if some of the keys get pressed, you may dial it to some other person also. So that's why proximity sensor is there in the phone. So it's the best example to measure the distance, right? Now moving on to the next topic. Now let us study two different types of sensors which are there in your syllabus, and they are very important one from exam point of view. First is ultrasonic sensor. So ultrasonic sensor it was sometimes used in place of an optical sensors, and in optical sensor we use a light beam to measure the distance, but in ultrasonic sensor we do not use light beam, we use a high frequency sound waves, which is also known as ultrasonic waves. This sound wave is above the normal hearing frequency, meaning we are not able to hear it, and are called ultrasonic. Frequencies around 40 kilohertz are common. So these three types of range of frequencies: one is subsonic sound, that is 20 hertz. Another one is sonic sound, 20 to 20 kilohertz, and ultrasonic sounds are more than 20 kilohertz. Now let us understand how does it work. The sensor first emits a short ultrasonic pulse. Suppose this is a sensor and this is a wall. This sensor emits a short ultrasonic pulses which strikes on this wall, and it creates an echo. Now this echo is being heard back to the sensor. So when the echo is returned, the sensor detects the target is present. Now it is continuously sending this ultrasonic wave to see how much the distance has changed since the sensor is moving up in front or this wall is moving up in front, and measuring the time delay between the transmitted pulse. So there is a time delay, obviously. Because of this time delay, it is able to measure how far is the object, calculate the distance between the sensor and the object. So this is how you measure the distance between an object with the help of an ultrasonic wave, by measuring the time delay created by the echo. Now what are the applications? Ultrasonic sensors can measure the distance to a wide range of objects: liquid level of control monitoring, trash level monitoring, and trash, like if you are putting trash in a bin, so how is the bin full or not, and vehicle detection in car washes, automotive assembly, and parking garages. So you can see from this application that ultrasonic proximity sensors are very useful in industries and in day-to-day applications, right? Like in some kids robot, like kids in school, they are making a line follower robot. So in line follower robot, they usually mount an ultrasonic sensor to check whether the robot is moving in the right direction or there is an obstacle in front of it or not. So this is the best example of ultrasonic sensor used by school kids to develop small kind of projects. Now moving on to our last sensor, which is nothing but Hall effect sensor. So this is what a Hall effect sensor looks like. There is a magnet here, and there is a sheet here, and on this sheet there is an electrical, it is connected to this high voltage DC supply, and sorry, this is high voltage DC supply, constant electric flow, and because of this magnetic field, as the flow is constant, it is scattered, and because of this electric field, it comes in a straight line, right? So the principle of Hall effect sensor is, as Hall effect sensors work on the principle that when a beam of charged particle passes through a magnetic field, these are the charged particles which are passing through the magnetic field, and this is the magnetic field. All right. The current beam is deflected from a straight line path. So current beam is, it was traveling in a straight line path. Now it's get deflected, it gets scattered like this. Thus one side will become negatively charged and other side will become positively charged. So one side of the plate, it may become negatively charged, and the other side of the plate may become positively charged. This charge separation generates a potential difference, which is the measure of distance of magnetic field from the disc carrying current. So this potential difference essentially helps us to measure the distance between this. So this is how, like this is an Hall effect sensor, it is a displacement sensor. So this is how you measure the displacement with the help of this potential difference created. So the typical application of Hall effect sensor is the measurement of fluid level in a container. So there is a container and there is a fluid in it. You want to measure how much the container is being filled by the fuel. So the container comprises of a float which is the permanent magnet attached to a top. एक फ्लोट इज अ टाइप ऑफ सब्सटेंस, एक आपका एक इंस्ट्रूमेंट होता है जो कि आपका कंटेनर के ऊपर लगा होता है, जिसके ऊपर एक परमानेंट मैग्नेट अटैच होती है. एन इलेक्ट्रिक सर्किट विद अ करंट कैरिंग डिस्क इज माउंटेड ऑन द केसिंग, और केसिंग जो है फ्लूइड की, उसके ऊपर आप इलेक्ट्रिक सर्किट लगा देते हैं. व्हेन द फ्लूइड लेवल इंक्रीजेस, जैसे ही बढ़ा, द मैग्नेट विल कम क्लोज टू द डिस्क, जो डिस्क के क्लोज आ जाती है मैग्नेट, एंड अ पोटेंशियल डिफरेंस जनरेट्स. दिस वोल्टेज ट्रिगर्स अ स्विच to stop the fluid come inside the container. So this potential difference, if it is high above a certain value, it will then go to the switch, and switch will automatically switch off, and the supply of the fluid in the container will be disrupted. So these sensors are used for measurement of displacement and direction of position of an object. And the best application is the fluid container, as I have discussed now. The Hall effect sensors and need necessary signal conditioning circuitry. You need to condition the signal so that the signal are properly fed. They can be operated at 100 kilohertz frequency. Their non-contact nature of operation, good immunity to environment containments, and ability to sustain in severe condition make them quite popular in industrial automation. So the best application of Hall effect sensor, apart from the fluid level measurement in the automation industries, all right, so that will be all. These two types of sensors are important from exam point of view in AKTU mechanical 5th semester subject of Mechatronics. So that is all that we will be studying right now in unit 2. So I will meet you in the next lecture, in which we will be discussing about important topics of unit 3. That will be all. Thank you. Jai Hind.